Hey everyone, and welcome back to another edition of your Advanced Math Notes. We are taking a look at Unit 5, Day 2 of our Oblique Triangles unit. We are continuing to talk about the law of sines, except now we're going to talk about the ambiguous cases. So we can use the law of sines when we're given an angle-angle side or an angle-side-angle triangle. But there's also a third case where we can apply the law of sines, and that's if we're given a side-side angle triangle. Now, if you remember back in geometry when we first started talking about the different types of triangles we could have, side-side angle was the method that we were not allowed to use to prove two triangles congruent. The reason being for that is if you're only given two sides and the non-included angle, there are actually two different triangles that could be possible. So it was not enough information to be able to prove two triangles congruent. In this case, we're not proving triangles congruent. We're problem solving with oblique triangles. And because there are two possible triangles that could be formed, we need to figure out, first of all, how many triangles are possible based on the information in the problem. And then if no triangles are possible, then we need to understand that. If one triangle is possible, then we can problem solve as we have so far using our law of sines. Or if two triangles are possible, then we need to problem solve for both potential triangles. So the way that we're going to determine how many triangles we have is by comparing our given angle. So once we see that we have a side-side angle triangle, we're going to determine if that angle is acute or obtuse. Acute meaning less than 90 degrees or obtuse meaning between 90 and 180 degrees. Please keep in mind that although it says angle A on your flowchart, that really stands for any angle that's given. So it could be called anything. You might not have a triangle that's named triangle ABC. So this A stands for any angle that's given in the problem. Okay, which also means that side A doesn't necessarily mean side A. It's the side that's opposite your given angle. And side B doesn't necessarily mean side B. It's the side that's not opposite to the given angle. In other words, it's the side that's adjacent or next to that given angle. So if the given angle in your problem is obtuse, we come down here, we have two possibilities, either one triangle or no triangle, and it's fairly easy to determine the difference between them. If there's one triangle, then the side across from your given angle is greater than your other given side. If your side is less than or equal to your side not across from the given angle, then you have no triangle that's formed. If the given angle is acute, then, and again, the side across from the given angle is greater than your other side, then you have one triangle. But if that's not the case and your angle is acute, then you need to find some more information. You need to find the height of your triangle using the formula B sine A, or in other words, the side next to your given angle times the side sine of your given angle. And then you're going to compare the height to the side across from your given angle. And if that side is less than your height, then you have no triangle. If they're exactly the same, which almost never happens, then you have one triangle. Or if your height is shorter than your other two sides, then you have two possible triangles. So again, if you have no triangles, your problem ends here. There's no problem solving to do because you don't have a triangle. If there's one triangle, then you're going to use the law of sines just as you always have. If there are two triangles, however, then you need to problem solve for both possible triangles. So you're going to use the law of sines to find one of your other missing angles. And then your original angle in your first triangle is whatever you get. And then in your second triangle, the other triangle that's possible is supplementary. That angle is supplementary. So we find the angle in your second triangle by just subtracting from 180. And then from there, we use the given information in each set of triangles to find any other piece of missing information in either the first or the second triangle. So that's obviously something we're going to need to do a little bit more practice with in class, which we'll do, but please understand that that with the law of sines and given an SSA triangle, there are a different number of potential triangles. It's why we call it ambiguous. We don't know how many triangles we could form. So we need to problem solve that first, and then from there, problem solve if we have no triangles. If we have one possible triangle, we do what we did last class, or if there are two possible triangles, we need to find the information for both sets of triangles. So we'll have two possible sets of answers. Okay, so just in summary, to use the chart, we first ask ourselves, is the triangle right or oblique? If it's oblique, what type of triangle is it? Can we apply the law of sines to it or the law of cosines? If we have to apply the law of sines, is it an easy case like we did last class, or is it an ambiguous case, a side-side angle case, where we have to determine how many triangles are formed first? And please come in next class with any questions that you might have, and we'll practice these problems together. See you then. Bye-bye.